process of protein intake and utilization for bodybuilding athletes is a multifaceted and intricate journey that requires a thorough understanding of nutritional biochemistry and metabolic processes. Proteins serve a pivotal role in the growth, repair, and maintenance of muscle tissues, making them indispensable in the regimen of bodybuilders. This narrative delves deep into the scientific nuances of protein processing in bodybuilders, exploring the sources, biochemical pathways, and strategies to optimize protein utility. Structure and function of proteins. Proteins are complex molecules composed of chains of amino acids linked by peptide bonds, with 20 standard amino acids forming the building blocks. Among these, 9 are essential as they cannot be synthesized endogenously and must be obtained through diet. The branched-chain amino acids, BCAAs, namely leucine, isoleucine, and valine, hold particular significance in bodybuilding. They directly stimulate muscle protein synthesis, MPS, a process heavily influenced by leucine, which activates the mTOR pathway. Furthermore, proteins support muscle synthesis, enzymatic and hormonal production, and cellular structural integrity. Dietary sources of protein. The effectiveness of protein intake depends on both the quantity and quality of sources consumed. High-quality or complete proteins, such as those from animal sources like whey, lean meat, fish, eggs, and dairy, provide all essential amino acids in sufficient quantities. Some plant-based proteins like quinoa and soy also qualify as complete proteins. Incomplete proteins, lacking one or more essential amino acids, can be prevalent in plant-based sources but can be consumed in combinations to form a complete profile. Proteins are rated for quality using indices such as biological value, BV, and protein digestibility corrected amino acid score, PDCAS. Whey protein often receives a high BV, nearing 100. Protein supplements like whey protein concentrate, casein, egg protein, and mixed plant proteins offer varied absorption rates, ideally chosen based on the timing relative to training sessions. Digestion and absorption. Protein digestion begins in the stomach with hydrochloric acid denaturing proteins and pepsin initiating peptide breakdown. The digestive process continues in the small intestine with pancreatic enzymes further reducing peptides into free amino acids and small peptide chains, which are thereafter absorbed through the intestinal walls into the bloodstream. Protein metabolism and muscle protein synthesis. Protein turnover in muscle tissues involves continual synthesis and degradation. An anabolic state, marked by muscle protein synthesis outpacing degradation, leads to muscle hypertrophy. Key regulators of MPS include the leucine-driven mTOR pathway, insulin, and resistance training-induced muscle damage, all contributing to muscle repair and growth. Advanced protein distribution strategies. Optimal protein distribution involves timing intake to coincide with energy expenditure and muscle recovery phases. Pre-workout protein facilitates amino acid availability during exercise, while post-workout protein within 30 to 60 minutes optimizes recovery and muscle synthesis. Nighttime protein intake, such as casein, promotes nocturnal muscle anabolism. Risks of inappropriate protein use. Excessive protein intake can lead to undue metabolic strain, including potential renal overload in predisposed individuals and gastrointestinal distress due to incomplete digestion. Phasic adaptations. Bodybuilders adjust protein strategies according to training phases. In bulking phases, caloric intake rises with a protein proportion of 20 to 30%, whereas during cutting, protein intake is elevated to protect lean mass. Conclusion. Managing protein in bodybuilding demands an acute focus on quality, quantity, and strategic timing aligned with the athlete's metabolic needs. Personalized nutrition plans enhance muscle hypertrophy, optimize recovery, and maintain metabolic health.